Hello guys, I'm back. Welcome to another video to my Chemical Process Engineer Challenging on LinkedIn. Today I will talk a little bit with you about Opex. Opex is part of the structure of a proposal or of a project. As I already have told to you, we have the CAPEX, Opex, and it's important also to verify or to define the reliability and availability of a project. And today, Friday afternoon, almost night here in Brazil, I was revising a Opex spreadsheet. In fact, I was not revising the Opex spreadsheet. I was asked by the business to verify what could be saved in the Opex. And when you are dealing with a project, it's important to you understand or to you verify what are the measures contribution for your Opex, or what are the major contributions for your CAPEX. It's the famous law of the 20-80. So 80% of your results will come from 20% of your efforts, or something like that. What's the main point here? I have a series of activities or contributions for my Opex, and I must to be able to have a lower Opex. Instead of verifying how much is the license software, for instance, instead of defining 10,000 US dollars per year, it is 15,000. It doesn't matter, because in the summing up of everything, this will represent less than 1% of my Opex. So if I expend energy to verify if the license is 10 or 15 or 20, it is a waste of time. We need to verify what are the measures contributions for the Opex in most of times in a project. First is the energy. The energy is one of the main contribution for your Opex. So if you can design a process that spend less energy, it's better. Or in the other hand, talking about business, if business are able to deal or to negotiate lower fees for the energy consumption, it's better for the project. Another thing that consumes a lot of the Opex is the insumes, or is the raw material value. If you are able to produce more with the same amount of raw material, better. If you can reduce the losses of your process, better, because this way you will you will have a better KPI for the money expended by the ton of production. That is very important also. And another contribution, big contribution for Opex of an industrial plant is the personal payments. How much you expend to people that works in a plant, for instance. And that's why most often we try to automate as much as possible a process, because you remove people from the operations, and with that, of course, that you reduce the payments. And when you reduce the payments, you are reducing also the Opex. And observe that the Opex related to personal is a fixed Opex. It doesn't matter if I running at 100%, 75%, or 50%. Considering that I need to keep the same team available for the operations, I will spend the same amount of money. So as less I produce, my KPI of Opex decreases. It gets worse, because I am producing less and having the same amount of money spent, so I am increasing the cost of production. So we try every time is possible be as the full capacity as possible. Every time you want to run your plant at the full capacity as possible. But there are other costs that is not fixed costs, they are relative costs. So the energy, it's not one if I am at 100% and if I am at 50%, the amount of money that I spend is different. But how much different depends on the strategy that you have considered for your project. For instance, if you are using a variable speed driver, most often when you decrease your production, you are able to decrease also the power consumption of your plant. It's not necessarily proportional, but you can reduce a lot the costs associated with that. But let's suppose that I have a compressor that is feeding a gas for a column. It's normal have this way, this kind of process that I'm talking to you, it's common in the air separation industry. I have a air compressor and a feeder column to liquefy the air and with that be able to separate or to split nitrogen, oxygen and argon. And if for any reason my client or my customer decreases the consumption, for instance, I need to reduce the plant capacity. And when I reduce the plant capacity, instead of having a variable speed driver on the air compressor, what I do, I open a vent valve for atmosphere. We are talking about air, it's not flammable, it's not toxic. So while I am having some kind of issue in the process, instead of stopping my machine, I can, for instance, open the vent valve and for a period of time, I will be able to keep it running and waiting for the adjustments in the process to feed the full capacity to the column again. When I do that, verify that my compressor, my air compressor, keeps running at 100%, for instance, okay? But what is meaning here? I am venting for atmosphere. If I have a way to reduce the speed of the machine, I could deliver or I could feed my column with lower gas flow and with that reduce also the cost of energy. If I need to vent and I am feeding the column and venting the raw material, I am expending much more energy than if I just would be able to reduce the rotation of the equipment, for instance. If I rotate the compressor, it's the same because the amount of flow that is going in there and that's going out, eventually you will decrease a little bit the pressure at the discharge, but the power consumption is quite the same. So depending on the strategy that you use in your process, when you reduce the plant capacity, you can lower the energy produced a lot, or you can lower the energy produced not too much. And that influences the Opex. And why the Opex is so important. When the business do the verification, the feasibility study, the economical feasibility study of the project, part of this feasibility study is considered in the CAPEX, how much you expend to be able to erect the plant, but you have also the Opex in the equations for the EVT or the present value, for instance, calculation. As lower is the Opex needed to have more product, better to you, because you will it's favorable to the feasibility study, to economical feasibility study. The company will get more revenues with a lower investment in terms of capex, and also a lower investment of terms of Opex. So this is one of the activities that I do as a chemical process engineer working with plant design. This kind of interaction with the business team depending on the size of the company that you are working on, depending on the structure of the company you are working on, and of course about the level of your expertise or the level of experience that you have in the company. It's not something difficult to learn, but when we are dealing with thousands of dollars, millions of dollars, that of course that we must have some very, very good attention, because the numbers that you produce in plan design, you will be used by the business to verify the feasibility of a project. And the feasibility of a project will guarantee the revenues not only for the stakeholders, but also for you. So if something goes as unexpected, as not expected direction, this is not good to anyone. So this is it that I would like to share with you today. In fact, let me tell you that I am very tired. Today is Friday, almost evening, and you can see by my face that I am not with the best. I am not beautiful, but today I am less beautiful than usual. And I am just recording this video for you today because my commitment with the challenge, the Chemical Process Engineering Challenge on LinkedIn. So this is something that you should consider what you are committed, that even though you are very tired, you keep doing to improve your chemical process engineering and career. So this is the point here that I would like to share with you. When you are committed to getting something, it doesn't matter or it's not so important what happens outside. If you are able to stand up and do something to reach it, you should do that, because this way it's the only way that you will get a successful career. So bye bye.